to the bottom, I go back to the top of the slide. Where I stop and I turn and I go for a ride. Till I get
Okay, so
to the
welcome folks, we're
bottom,
going to start
I
part 2 here. We're going to be talking about dimensional analysis, and we'll also be talking about density problems too. To start off, remember dimensional analysis is all about changing and converting units. We're going to be using it all year long, so you might as well just get used to it. Okay, so for our conversions here, we start simply with our known. Okay, so for example, we have a known here of 58.3 milligrams, and we want to convert that into kilograms. Now before we go ahead and do that, let's think. Okay, we've got our number line here, we've got our base unit, grams, we are over here at milligrams, which is smaller, and we've got kilograms up here, which is much larger. So to convert, not many of us just know straight away the conversion from milligrams to kilograms, so we're not going to do it. Okay, instead we're going to convert first to grams and then to kilograms. Alright, so to do that, okay, we've set up our known on top. Now we want to set up the other one on, we want to set up milligrams once again to cancel. So we do that with a conversion factor. We have grams and milligrams. Well, milligrams needs to be on bottom to cancel. Grams is on top. And which one is the larger one? Grams. So in 1 gram we have how many? 1,000 milligrams. Remember that milli means 1,000. Now our milligrams cancels out. Okay, and we're ready to move on to our next. Now we know how to convert from grams to kilograms. Do the same process over again. So we have grams on bottom, so it cancels, kilograms on top. Larger unit gets the 1 kilogram. There are 1,000 grams. Alright, so we multiply across. Okay, multiply across, divide if need be, and what we would end up getting here, well, let's go ahead and run the calculator. We have 58.3 divided by 1,000 divided by 1,000, and that comes out to 0.0000583. Alright, so 0.000583. That's not necessarily a good number for us there, so we want to change that into scientific notation. So we would end up going 5.83 times 10 to the negative, what would that be? 1, 2, 3, 4, 5. Negative fifth, and what's our unit that's been left over here through all the cancellations is kilograms. Alright, and that would be our final answer. Alright, so let's move on to another problem. We're going to change 0.0675 decimeters to millimeters. So once again, let's think about our number line and think how we're going to have to do this. We've got our number line here, we've got meters is our base unit, millimeters is out here, decimeters is right over here. Now we're in decimeters, so not many people, okay, centimeters in between there. I mean, we could go from decimeters to centimeters to millimeters, but a lot of us don't necessarily know that off the top of our head. How many decimeters are, how many, you guys aren't really comfortable with that yet. So what I want you to do is to go to simple known units. So decimeters to meters. That's how I would first go. Decimeters, that's how I am going to go. Decimeters to meters, and then meters, once we find that, we're going to go from meters to millimeters. So 2 steps, we're actually going to move one way and then the other. So we start off with our known, once again, 0.0675 decimeters. It's very important we put that unit in there, otherwise you're going to have a chance of forgetting and it just makes everything more complicated. So we want to set up decimeters to cancel. That means it goes on the bottom. Alright, meters on top. In 1 meter we have 10 decimeters. Okay, so decimeters now cancels. From there, we want to go from meters to millimeters. So in meters we want it to cancel. We want millimeters to be our final unit. Meters cancels. So in 1 meter there are 1,000 millimeters. Okay, so let's get out the calculator again for that. We have 0.0675 divided by 10 times 1,000, and that gives us 6.75. 6.75. And what's our unit? 6.75 millimeters. And that would be our final answer. Okay, so let's move on to our other problem. Okay, so far, if you've noticed, we've left this bottom portion here blank. Okay, what exactly goes in here? That kind of is confusing for people. But we leave that bottom portion there just in case we have a complex or a compound unit. Okay, so if we look at this here, we have 1.89 grams per milliliter to kilograms per milliliter. So when we have this, what we do is we end up saying 1.89 grams per milliliter. Okay, that's how we end up writing that there, 1.89 grams per milliliter. We're going to convert that to kilograms per milliliter. So let's think. We want to get rid of grams, so we need grams on bottom. We know the conversion to kilograms. So in 1 kilogram, there are 1,000 grams. Grams cancels. Now, if we look, what are our units left over? We've got kilograms on top, milliliters on bottom, which is what we want right here. Yay. Okay, so we multiply across. We have 1.89 divided by, because it's on bottom, 1,000, and that gives us 0.00189. So we have 0.00189. We could convert that to scientific notation also. So we put 1.89, okay, that changes into 1.89 times 10 to the negative 1, 2, 3, negative 3 third. And what is our unit here? Kilograms per milliliter. Okay, so that would be our final answer for this. Okay, let's go ahead and do our last type of problem here, a simple density problem. Okay, density, remember, density is equal to mass divided by volume. Alright, now our unit at the very end is going to be, since it's mass, we have grams per milliliter, so we're going to start off in grams. Okay, that's our final unit, should be in grams. But here's the question. What is the mass of a liquid that has a density of 2.0 grams per milliliter and a volume of 0.025 liters? Now, first things first, if we have units of the same thing, say volume for instance, that aren't in the same unit, we need to change it. So the easier one to change here is this 0.025 liters. So we're going to convert that first. We use dimensional analysis to figure that out. 0.025 liters. Okay. In 1 liter, because it's the bigger unit and we want it to cancel, that goes on bottom, we have 1,000 milliliters. And if we multiply across, that ends up equaling 25 milliliters. Now, that's not our final answer. That's just, we needed to convert something first. Okay, so we've got density equals mass divided by volume. We need to rearrange it so we get mass is what we want. Now to do that, okay, we ended up multiplying both sides by volume. Alright, now our volumes cancel, so we've got V times D equals M. So, our V is 25 milliliters times density, which is 2.0 grams per milliliter, is equal to mass. Now, if we think here mathematically, we've got milliliters on a bottom, and we've got milliliters on top, which makes them cancel. So it's really 25 times 2 equals 50 grams. That's how much we have there. Alright, so there's a quick review over a couple problems. We've got dimensional analysis that we've covered, and a little bit of density. Okay, those are some of the big types of problems that we will see in Chapter 3. Remember, if you have any questions, come in and ask me. I'll be more than willing to help you. I'll catch you later. Have a good day.